So in this question, chlorine is used to prevent the growth of a bacteria in a swimming pool water. It reacts as shown. So there's a reversible reaction. When we add chlorine to water, it will form HCl and HClO. By giving the appropriate oxidation number, why this reaction is a disproportionation reaction? Because if the same element is oxidized or reduced, here chlorine is 0, but in HCl chlorine is -1, and here each oxygen is -2, hydrogen +1, so chlorine should be +1. So what happened? Chlorine is 0, it changes to HCl, in which the chlorine is -1, so that is reduction. Whereas chlorine is 0, in HClO it changes to chlorine, oxidation number is +1, so that is oxidation. So because this happened for hydrogen, there is no change. As you can write for hydrogen, each hydrogen is +1, each oxygen -2. So for hydrogen and oxygen, there is no change. Only change is happening for chlorine, and in one compound formation it is reduced and the other one it is oxidized. So same element oxidized or reduced, oxidized and reduced. That's why we call that as disproportionation reaction. So 1 mark is for mentioning the change to reduction, 1 mark is oxidation, another one is just referring that same element is there. State and explain the effect on the position of equilibrium if concentrated hydrochloric acid is added to a sample of chlorinated pool. So what we will observe, because in terms of reversible reaction, if we add hydrochloric acid, if we add hydrochloric acid means we have more product. So if we have more product, equilibrium will shift towards the left hand side, and if the equilibrium is shifted towards the left hand side, so it means the yield will decrease. So addition of hydrochloric acid will shift the equilibrium towards the left hand side. Or more hydrochloric acid react with HClO, form chlorine and water molecules. In a similar reaction, chlorine reacts with sodium hydroxide to make household bleach. The concentration of NaClO in diluted bleach was measured by titration of 25 cm cube of sample. Approximately 1.5 gram of sodium solid potassium iodide and 10 cm cube of hydrochloric acid is added. So first we have to complete the ionic equation. So how to complete the ionic equation? To balance, because it's a redox equation, to balance oxygen we add water, to balance hydrogen we add proton, so two are there. So and then to balance the charge we add electrons, so net charge -1 and +2, so this is +1 and here is -1. So we should add electrons to reduce the charge, so we should add 2 electrons here. In the second equation there is no oxygen involved, hydrogen involved, iodine is there, so left hand side we have 1, right hand side 2, so we put 2, iodine is balanced. Then the charge is -2 here, because 1 iodine is -1, 2 iodine -2. And here we have net charge 0, so because we can reduce the charge, that's why the electron will be there on the product side. Then write the overall equation. How to write the overall equation? We make the number of electrons same and add. But in this equation, in this case, they're already same, so we just have to add the two equation. So ClO plus 2 protons plus 2 iodine result in a formation of a chloride ion plus water plus iodine molecule. Then the iodine in the sample of a thiosulfate is titrated with a concentration. This is a volume of thiosulfate and this is a concentration. Calculate the number of moles of thiosulfate. So to get the moles, we have moles equal concentration into volume. Concentration is 0.05, volume is 24.20, but that is in cm cube. So we should convert into dm cube, so divided by 1000. So when we divide this by 1000, this will give us the concentration as 1.24 0.21 into 10 to the power minus 3 moles. Then to get the moles, this is the moles of thiosulfate. In the next part, calculate the moles of ClO. So to get the moles of ClO, this is the moles of thiosulfate. As if I write this equation again, because we need this equation, the previous equation which was there for reaction, so that we can work out the number of moles of ClO. So this equation was ClO was there plus ClO plus hydrogen ions are there. Two hydrogen ions, two iodide ion gives chloride ion plus water plus iodine molecule. So ratio between iodine molecule and ClO is 1:1. But when you check the ratio between iodine and thiosulfate, that is 2 like when we check the overall ratio here, iodine and thiosulfate, so that is 2:1. So first what we do, we'll get the moles of iodine, and what moles of iodine we'll get the same number of moles of ClO, because the ratio between them is 1:1. So how many moles of iodine you will get, the same number of moles of ClO ions will be there in the diluted bleach. Diluted bleach, the bleach which we are titrated or use in the titration. So when we work out the ratio here, for thiosulfate, I'm using this space, thiosulfate to iodine, that is 2:1. So if we have 1.21 into 10 to the power minus 3, then this will be x moles of iodine. When we cross multiply, this should be 1.21 divided by 2. 1.21 into 10 to the power minus 3 divided by 2. That will give us the moles of iodine. That is 6.05 into 10 to the power minus 4 moles. And because the ratio between iodine and chlorate, ClO, is 1:1, so the same number of moles of iodine same will get. It's the same ratio, so it will be 6.05 into 10 to the power minus 4 moles will be there. Is it clear, this part? Then the next part, this is a moles in diluted bleach, but originally bleach, because they ask, hence calculate a concentration. Okay, we need a concentration. So what is the volume of a diluted bleach? Bleaches titled 25 cm cube of bleach was prepared, and approximately, so that's the volume of the bleach, that is 25 cm cube. So we need the concentration is moles divided by volume. So moles we already calculated, 6.05 into 10 to the power 24, 10 to the power minus 4. So moles of ClO were 6.05 into 10 to the power minus 4, and the volume was 25 cm cube divided by 1000, so 0.025 decimeter cube. To get the concentration, that is moles by volume, when we divide the two factors, we'll get the concentration, which will come out as 2.42 into 10 to the power minus 2 mole per decimeter cube. Then 1.5 gram of potassium iodide contain 9.04 into 10 to the power minus 3 moles of iodide. Use your answer to B2 and B4 show by calculation why this amount is suitable. Basically, when you check the first part, when we wrote the balance equation between the chlorate reacting with two proton, two iodide ions are there. As a result, it was forming chlorine gas and it was producing a water molecule and then iodine molecule. Chloride ion was there. So the ratio between chlorate and iodide ion, they're saying like potassium iodide is 1.5, which is having 9.04 10 to the minus 3 mole. Why this is enough? Like why this is more than enough or it is a suitable amount? So the ratio between the chlorate ion and iodide ion is 1 is to 2. So if we have like in the question how many moles were there, the moles were 6.05 into 10 to the power minus 4. So how many iodide ions x cross multiply? So the amount of iodide ion needed is 1.2 into 10 to the power minus 3. That is what we need. But we have more than what we need. In the question we have extra. So it means that is why it is suitable amount. Because when we took the ratio, iodide ion which we need for a complete reaction, this is what we need for a complete reaction. But we have more than what we need. That's why this is a suitable amount for reaction. Otherwise, what might happen? Not all of the chlorate ion reacted with iodide ion if iodide ion is smaller in quantity. A student carry out titration measured the mean average titer as 24.5. What is the percentage difference in this student titer compared to the accurate value of 24.20? So percentage difference when we are taking up, if we have the standard value, so the difference in the two value, if you are calculating a percentage difference, that is a maximum minus minimum divided by standard into 100 or accurate. So maximum value is 2.24.50, minimum is 24.20 and the standard is 24.20 into 100. So when we simplify, we will get the percentage difference of the two, which is about 1.24%. The difference between the student mean titer and accurate value was not due to limitation of the accuracy of measuring instrument. Suggest one possible reason, like student value is 24.50, but in practical, the accurate value is 24.20. Why there is a difference? Why student is not getting the same? He's getting a more volume. He added more volume as compared to what should be needed. So what could be a reason? The judgment in the end point, or because here iodide ion is changing into iodine molecule, so judgment is there, the like in, or error might be there in identifying the end point or appearance of the color not recognized by the student, or he might added a starch too early, because when we add a starch or starch early, then starch will form a complex with iodine and we need a relatively greater amount of uh, thiosulfate for a reaction. So what could be an error? So mainly you can mention error in the judgment of color change of iodine at end point that leads to an error or the wrong result. Suggests one damaging effect to the upper atmosphere which could be caused by the presence of the chlorine. Um, the chlorine, as we discussed in unit 1, that chlorine can undergo a free radical substitution reaction and it can cause depletion of ozone. So it deplete the ozone, or ozone depletion is one of the reason why we don't use CFCs or chlorofluorocarbons. When carbon dioxide gas dissolve, it may eventually form a mineral such as magnesium carbonate and calcium carbonate. State the result of a flame test carried out on these minerals. So calcium is a brick red, but magnesium there will be no visible change, no visible color change will be there. Or calcium you can mention red or a brick red or red orange or yellow red is also correct. Then magnesium carbonate and calcium carbonate both undergo a thermal decomposition but different stability. How to detect the thermal decomposition occur, how to measure, how measurement you take to compare, and how to make a fair comparison. You may include the diagram, but if you wish, but it is not essential. So, but the diagram will be same. We'll make a test tube connected by a delivery tube to a lime water. How to detect when the thermal decomposition occur? For that, we will use a lime water because when the lime water will turn milky, we can identify. The measurement you make to compare the stability will measure a time taken by lime water to change the color, like how much time the lime water is taking to change the color. If a lime water turned milky in a short time, it means it decomposes at a low temperature. If lime water takes longer time, so it means it is decomposing at a high temperature. How to make a fair comparison? So amount should be same amount of the solid as well as the heat source, the constant heat source should be there. So these are the factors which should be same. So you can write this experiment in your own words. State and explain, like as you can see, this is a figure. Normally the same figure is there. Metal carbonate test tube is there and lime water connected. State and explain which two carbonates are the most is more stable to heat. So which of the two carbonate, as we know, sodium carbonate and potassium carbonate are stable to heat. It does not decompose on heating. But in the context of the question, you have to tell here because state and explain which of the two carbonates more stable. So in terms of these magnesium and calcium, so we expect thermal stability increases as we go down the group. And what is the reason for that? Because as we go down the group, the size of the positive ion or the charge density is decreasing. So magnesium causes more distortion, which reduce or weaken the bond in carbonate, so it can decompose at low temperature. Whereas calcium is larger in size, so cause less distortion. So bonds are relatively stronger in carbonate, so take longer time to decompose. So we expect that calcium carbonate to be more stable. And as we go down, the stability will also increase. So same question is there, the carbonate of group 2. The stability of a carbonate can be compared. State the measurement that you make in this experiment. So what we can measure a time taken by lime water to turn milky. Suggest 3 ways to make sure that we are carrying out the thermal stability fairly. So three variable, like we should have a same heat source. We should take the same amount of or same moles of these carbonates. Same amount of the lime water should be there because if amount of lime water is different, then it will lead to a different result. Same size of the solid, because if one is powdered, another one is large lumps, then it will be not fair. State the trend in thermal stability of a carbonate. As we go down, the thermal stability increases. And explain this trend, again the same reason. As we go down, the metal size or metal ion size is increasing, the nuclear or the charge density is decreasing, so cause less distortion to the negative ion, which reduces the strength. So this was the assignment related to group 2 and group 7. So last session we discussed MCQs and today we did the structure questions. So next week we will start the organic chemistry of alcohols and carboxylic acid. Any question or a doubt related to the class?